In this lesson, we are going to talk about commit messages. Yes, we are dedicating an entire lesson to those pesky messages that we have to add at the end of a commit. And if we're dedicating an entire lesson, that means that those commit messages are actually more important than what you think. So we need to stop taking those commit messages as a chore and write some obscure messages that are not understandable, and we need to take those commit messages seriously. Not only does the whole team of developers need to write commit messages in the same conventions, if we keep those same conventions, usually something called conventional commits, if we keep those commit messages in a convention, we can reap the benefits by doing automated release. Automated tagging, automated version, automated NPM publish, automated Slack publish, automated change logs. So a lot of things can be created automatically by proper commit messages. So this is why those commit messages are actually more important than what you think. So here's the plan for this lesson. We're going to start to talk about the job of a commit message and understand that the commit message is actually more important than what we think. We are then going to talk about the conventions of how to write commit messages. Specifically, we're going to talk about the popular convention that is called conventional commits. We'll learn how to use conventional commits to write those commit messages. We are then going to talk about reap the benefits of those conventions of commit messages by doing automations. If you write your commit messages using conventional commits, you can then create automations based on those commit messages. So we're going to use a library that is called semantic-release to create automation based on our commit messages. So this is going to be really cool. And we're going to learn if the commit messages are so important, we need to learn how to fix them. So how do we change the commit message? If accidentally we wrote something wrong, how do we fix our commit message? We are then going to talk about protecting your commit message. So from what I experienced, if working on large developer teams, if you want something like conventional commits, if you want your commit messages to be in a certain conventions, you have to enforce it. If you don't enforce it, it's going to be breached. So we'll learn how to enforce the commit messages to be like conventional commits among all our developers. So all developers will have to write those commit messages using conventional commits. We'll learn how to enforce it. We're going to use something called commitlint to check the commit messages before the actual commit is made in one of the Git hooks. And as usual, this entire lesson is available in Academy, step-by-step guide, the source code, everything is completely free. Academy is open source learning academy, everything here is free, no need to register, no need to write your email, just star us if you like our work, and that's it. This is the plan for this lesson. Let's start by understanding the job of a commit message. When I started working with Git, I saw those commit messages as a chore, really wrote them without thinking twice. After working with a while, working with the right convention, it kind of opened my mind to it's not only a chore, but it actually helps me understand the Git history, plan my code better, automate my releases. There's a lot of job in those commit messages, which I wasn't aware at first when I started working with Git. So let's talk about that and understand how important those Git commit messages are. So the obvious thing that we know the commit messages do is make your Git history readable, right? So you need to see the Git history as the evolution of your software. So you see the evolution of your software, and those commit message describe the progress of your software, right? Now, think about this. Think of like you're working with a team of 100 developers, okay? Each one has his own convention, his own phrasing. So it's like you're reading a story of the evolution of your software, but it's written by 100 different developers. Suddenly it makes it really hard to understand. It makes it very hard. It's not very much readable, the history. But those 100 developers actually need to work with the same convention. So it kind of need to look like a single author of the story. And that makes things much more readable. So you have to have identical writing convention between all the developers, which makes the Git history much more readable. Now, not only that, there is certain, in the convention that we're going to touch in this lesson, we're going to talk about certain commit convention that really make a commit message more important, like fix, like feature, like breaking change. Those things really stand up. So when you're reading the Git history, you really can focus on those important commits. And it really helps when you debug your code. And so you really can immediately identify those critical commits. You also will learn about that convention. It can also reference other information that is also important. Like it can reference, your commit message can reference a Git issue or a task in Jira or a task in ClickUp, or you can write, if you pair program with another developer, you can write his information, who reviewed this PR, this commit, and so on. So it can really reference additional important information. Now, the thing that really took me a while to understand when I wrote those Git message, that it actually helped me plan my, like when you code a feature, you have a certain plan. And maybe you write an RFC or a general plan or plan in your head, whatever you're doing, you're planning your work. And then you start working, and maybe you're working on a big feature. So you plan your work and you say that feature will have like a few PRs, not one single PR, but I'm going to split it according to some plan. So you plan and then you start coding, and things usually that do not match the plan that you started at first. Some things might change during your when you actually write the code, that you understand that you need to modify your plan a bit. Now, why am I saying this? Because when I start work and I have a plan, I start splitting, maybe I stack my PRs to a certain plan, and I start coding, and then I start to write those commit messages that stand up, like feature, fix, breaking, change, those commit messages, often when I write them, it makes me rethink of my plan. So, because a lot of the times those things, those fix feature can stand in their own PR. Not all the time, by the way, but sometimes they make you rethink and plan, hey, if I split it to a different PR, I can actually merge this fix quicker to main. I don't need to wait for my entire feature. So those really makes me rethink my plan and merge more code to main than I additionally planned. So this is a really important aspect of those commit message that I find make my work extremely better. Now, the thing that I really want to focus on this lesson is the part of the automation. So if you have a convention for your Git messages, there is a lot of conventions that you can do based on those commit messages. For example, you actually don't have to bump your application version manually. Actually, it's best if you don't do it manually, because if you bump manually, it often subjective, and you bump it not in you bump the minor when you actually need to bump the patch. Things need to do automatically, and it needs to be according to the commit messages. So you actually don't need to worry about the version. It needs to automatically bump it. We'll talk about the automatic bump of the version later in this lesson. And also you need to mark your releases with tags, right? So you need to tag your code. And this is also something that needs to be done automatically. So we'll talk about automating those tags according to the commit messages. We're going to talk about the change log. You can npm publish, you can slack publish, you can do certain things based on those commit messages. Actually, a lot of libraries, you see the change log and the releases, you see when they specify what change, they actually place their commit messages, and you know it's done automatically. So this is a convention that is used in a lot of popular libraries, apps, packages. So this is another important aspect of the job of a commit message. So the job of a commit message is not only to write a short description, it's a lot more than you think, and it's very important to keep that commit message write properly. So we established that we have to write our commit message in a certain convention. The popular convention for writing commit messages is called conventional commits. And this is what we will learn in this lesson. How do you write your commit message in a convention called conventional commits? So conventional commits is a popular convention for writing commit messages. You don't have to install anything, just you need to follow their guidelines and their specification how to write your commit message. All developers will write in a similar syntax using the conventional commits, and later in this lesson we'll learn that how to enforce it, how to enforce that all our developers will write their commit messages using conventional commits. And it actually will help you, as we talked before, it's going to help you plan your work properly, how to split your PRs properly. It's going to actually make you rethink your plan and merge code more often to production. Now, let's start with our first example of conventional commit. So conventional commit, we'll talk later about all this section, has a type, optional scope, description, body, and footers. We'll specify each part of it later in this lesson. The most simple commit that we can write is a one-line commit. For example, feature, we're creating some feature. The exclamation mark we'll talk later is a breaking change. So let's write our first commit message. I'll go to my terminal. I'll open a new directory. I'll call it commit messages lesson. And I'm gonna cd to this directory, and I'm going to git init in this directory. So now I have a local git in this directory. Great. I'm going to create my first commit, and it will include package JSON. So I'm going to do npm init -- yes. This will create a package JSON file. So if I'll git status, I see that I have an untracked file called package.json. Let's create our first conventional commit that we created our package.json. So I'll git add package.json. It's probably best to actually, we know what's created for us, but it's probably best to actually examine that you're okay with those changes, maybe do a git diff. But if everything is okay, we're going to git add package.json. After git add package.json, we can git status. We see that changes to be, this file is now staged, and it's going to be committed if we commit our code. So we'll write our first commit, conventional commit, and we'll do a git commit -m. We created nothing special, not a feature, a fix, just a chore. We created our initial package JSON. And this is our first conventional commit. Now, notice a few things that I wrote in my commit. So nothing special here. I started with something called type. So the type, we'll talk about this. It could be fix, feature, docs, test, CI, build, different kind you can place here, the type of change that you are creating. So this is the type of change, after which there are dots, and created our initial package JSON. This is called the description. We have the type and a description. In conventional commits, we see it as the type. We didn't add a scope, we'll talk about this later, and a description. So this is our first commit using conventional commits. Let's give another example of conventional commit. In this example, we'll give a more robust example with all the blocks of conventional commit. So in conventional commit, we have the type, the optional scope, the description, optional body, optional footers. So let's see an example with all those parts. So I opened our project in VS Code. Now let's add a file. Let's say I'm adding a README file. Okay, and I'm placing a title, Academies git commit lesson. Okay, so I modified the README file. Now, let's go to the example. What I want to do is I want to, not all your commits are single line. So in the previous example, we showed that we did a git commit -m, and we just had a commit with a single line. Now, a lot of commits that you do will have a single line, and this way is a shortcut to doing so. So just git commit -m, and then one line of the type and description and scope of your commit. Now, not all commits should be on one line. Sometimes you want to include a body, and sometimes you want to include footers. And as specified in the conventional commit, sometimes your commit is more robust than just a single line. And in this case, it's better to use git commit without the actual -m, just git commit. So I didn't git add, so let's do git status to see that we have the README file, git add README file. Now I want to enter a multi-line commit. So what will happen, I will do git commit without the -m. Now what git will do is git will open the git editor. Now usually the default git editor is Vim. I changed mine for Nano, but actually recently what I like to do is I switch from Nano to VS Code. You can actually have VS Code be your commit editor, which I found nice because I have Copilot, and then it can continue my commit messages. So instead of using Nano, I can configure my git editor. So I can do git --global core, I think config, no, it's, I think it git set config -- global core editor, and the editor is code -w. I think that's not, it's not set, it's just git config probably. So now if I do git commit, sorry. So now it opens the commit message in VS Code, which I found pretty cool because I can have my Copilot and everything that the setup that I have here. Everything here is comment, so it can be deleted, or you can add comments. It's not going to be included in the commit message. And in here, we did a docs, this is the type. So we modified the README file and added a title. After that, I can enter the body of a commit. So if I have something that is more, I want to include more details about the changes that I made, so I can do, I don't know, updated README, included required contribution data or stuff like that. I can add more blah, 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 blah. And after, notice that between the description and the feature, there is an empty line, and then you start the body. Between the section of the body is optional. Between the section of the body and footers, you have another empty line. And the footer will start with a word token. So you have different word token. Some organizations define their own word token. So I can have reviewed by John Doe or fixes 1, 2, 3. So this is a footer. You distinguish between a footer, since the body is optional. You can also include only footers. This is distinguished from the body by the word token. So you know it's not a body because it had the word token with dots and then the name. So this is my commit message. I save, and then this is committed. Okay, so what we did is we opened the Git editor by typing git commit, and this allowed us to type multiple line commits. You can configure VS Code if you want your IDE to be the Git editor, which is quite cool. I do it now, and I'm quite happy with that. And then I can type the scope, the type, the scope, the description, multiple lines of body, and multiple lines of footer. So we saw a few examples of conventional commit. It's quite simple. Just write your commit in a certain convention. If you're not sure, follow that documentation of conventional commits. And there's a lot of examples here in the site as well. So just to go over the template of conventional commit and the sections we have here. So conventional commit starts with a type. And it's the same here as well, the documentation, a type, an optional scope, an optional exclamation mark that mark if it's a breaking change or not. You remember when I told you that you read the Git history and some commits pops out if you're using conventional commit. So this is exactly a thing that makes your commit pop out. The exclamation point here marks a breaking change. So it's really easy to spot those commit that might issue a bug or change critical sections in the code. Description, this is required. So for now we have a type is required, a description is required, the body is optional, and the footers are optional as well. So let's talk about those sections here. Let's start with the type. So the type, it's the first part of the commit message. It's required in every commit that you create with conventional commit. And it basically says the type of change that this commit issued. So, and it's not set in stone, right? So later in this lesson, we are going to enforce conventional commits using something called commitlint. And in commitlint, you can configure what kind of types you have. I like to base my types on the Angular conventions, but sometimes I change it a bit. So sometimes I add in my configuration additional configuration for the type. But knows that it's not set in stone, but in a way it is set in stone because you're going to enforce it with commitlint. But what I mean is that you can set the type to be set in stone to the stone you want, if it makes sense. So you can say the types that you want. But after you set the types that you want in commitlint configuration, it's set in stone. Every developer has to use those types. So here's a few examples from the Angular convention that I like to use. So you have build if it's a type of change that is changing the build process, CI if it's changing the CI process, docs if it's changing the docs, feature if you added a feature, this will cause a minor version update. Fix if you fix the bug, this will cause a patch bump. Actually, those two are very important to remember because these we said in the lesson that we will create certain automation. One of those automation is regarding the version. So our version will be bumped in an automatic way. We will show how to do it using semantic release. Now, fetch and fix are actually commits that cause your version to go up. While fix is going to bump the patch, fetch is going to bump the minor. We're going to talk about semantic versioning in this lesson, but those two are very important commits. Those are the commits that bump the version. Those are the commits that also makes me think, is my plan all right, or should I split it to a different PR so I can merge this to main? So I always, when I create those commits, I always take a minute to think about my plan and replan if I need to split my PRs and my plan differently. Perfect performance improvement, refactor if you're factoring something, style if it's a style change, test if it's a test change. I like to add also chore if it's something that you need to do due to features that you added or something else. So those are the types. And you can base them on Angular, which is what we showed here. This is the Angular convention. This is also in the conventional commits. They also provide a link to the Angular convention somewhere. So let's say the types allowed by example. So this is the config conventional. You have the config conventional, and it's based on the Angular convention. So you can get inspired from the Angular convention regarding your types. So those are the types that in your commit method that signal what kind of change did this commit issued. So the next section of a conventional commit is an optional scope. Let's talk about the scope, which is described here as the optional scope here. So let's give an example. A scope, a lot of the time we can take our application and we can split it to sections. A good example is if you have on a repository, perhaps you have a directory called apps with multiple apps, and maybe you have also a directory for libs, for shared libraries, and maybe you have, I don't know, a few front-end apps. So you have, let's say, front-end 1 and another front-end 2, and a few apps like that. Maybe you have a backend 1. Maybe you have certain libs. For example, you have a variation of your MUI or your MUI design components. So it's clearly what our sections are in this example. But of course, you can. It depends on the software. But you can also when you configure your commitlint, when later we'll enforce things with a commitlint, we'll force all developers to write the commits properly. You can actually define the scope. So it's different between software. In this example, it's clearly that we have a few scopes. Each of our app is a scope, backend, front-end 1, front-end 2, and our MUI is a scope. So if, for example, I'm adding something in front-end in the MUI, let's say I'm adding index.js and console logging. This is the MUI lib. Okay, so clearly what I did is touched the scope of MUI. So a scope is a section, and we touched the MUI lib section. So my commit might look something like this, right? So let's git status. We see we have a change in the libs. So we git add libs MUI index, git status. So we have our file committed, and now we want to write the commit. We know that we wrote the commit in the scope. So the type that we did might be, let's say, chore, and then in brackets here, I'm adding the scope. So the scope here is MUI. So added logging information. So this represents the scope, the part of your app that you made the changes. And there's a few things why it's helpful. I think the main thing for me that it's helpful is, again, with the planning. So when you work with conventional commits, a lot of things make you rethink your plan. And this is also one of the things that make me rethink of my plan. What do I mean by that? If I have a PR and I see that I'm touching a lot of different scopes, so perhaps if I'm touching a certain scope, I can maybe separate to a more minimal PR. So often your PRs might reflect a certain scope. And if you're moving from scope to scope in a PR, it sometimes indicate that maybe you should split your PR to multiple PRs according to the scope. Not all the time, sometime, but it does make you rethink if your PR scopes are all over the place. It does make you think about your general plan. Okay, so this is one thing that I liked about the scope. Another thing that I really find the scope helpful is when viewing the Git history, especially when you debug. So let's say I have like a Git history, I see 1,000 commits. And I know that my bug is in a component that is in the MUI library. So I might look more carefully to the commits with the scope MUI. So this kind of limit also give you a good track of the commit that if you're looking at a certain scope, you will look at the commits of a certain scope. So it's really helpful for debugging, to understanding the evolution of that scope. So it's really helpful in that term. So just to summarize all the things I just mentioned, obviously the scope is optional, because sometimes you're not talking about a certain section. Sometimes, for example, if I modify the main package JSON, or modify the main lint files, or main ESLint configuration, or modify something that affects the entire project, so I might drop the scope in that case. But if I'm specifically targeting some feature in a scope, then I will add the scope. So the scope is optional. It will arrive as brackets after type. So I have it, or an example like we showed, type scope. You can split your project to sections, and you can also enforce those sections in your commitlint configuration. So in our case, the section was front-end 1, front-end 2, back-end 1, and MUI. But in each app, the sections are different, right? So the scope will say that the changes in this commit are targeted to a certain section. And it will also help you split your work better. Like we said about the planning, so it makes you rethink about the planning. If I'm touching a lot of scopes, maybe this PR is too big and maybe I should split it to smaller PRs. So the next section of a conventional commit that I want to talk about is signaling that the change you made is a breaking change, meaning the API that was before this commit is no longer supported. So a breaking change, let's for a second talk about the version in Node. The version in Node packages are made from 3 numbers, and it's called semantic versioning. So the rightmost number, or the least significant number, is signaling that it's called patch. And if you're fixing a bug, for example, you will increase the patch. So you didn't add a new feature, you just worked on an existing feature and solved a bug, so you will raise the patch number. And the middle number is called the minor. The minor is if you're taking something, like for example, a library, and you're adding a new feature. So you didn't change the API of the old feature, you're just adding something new. This is called the minor. The first number is called the major. And the major you increase when you have a breaking change, meaning that some APIs that were supported before are no longer supported. And this will issue a breaking change. Now, you are not, if you're working with a conventional commit, you have the choice that your version will be managed automatically. We'll introduce it later in this lesson. We'll introduce a package called semantic-release, and then we won't have to trouble ourselves with the version. The version will be updated according to our commit messages. So what semantic-release will do, it will look at the commit messages. And if the commit message, we'll look at the type. Remember, the type is the first section, the required section. The type can be fix or feature, for feature. So it will look at the type, and then based on the type, it will decide what the version should be. So if the type is fix, it will bump the patch, the rightmost number. If the type is feature, so it will bump the minor. And if the type is breaking change, which we'll talk about now, it will bump the major. Okay, so the idea is not to manage the version yourself, manage it automatically. So we have to understand how we're signaling in a commit message that this commit has a breaking change. So what we do is let's go back to our example. So let's say I'm doing some change here, which is this is a breaking change. So I made a change in MUI, which is a breaking change. So what I can do is I can signal it in, there are actually two ways. So one of the ways, let's add the file and let's commit. One of the way I can signal that this is a breaking change is by adding exclamation point. I changed the API of MUI and the old API is no longer supported. So this is one example. If I'm adding exclamation point, and it doesn't matter what type you are using, just the point that you're adding an exclamation point will mark that the change you made in this commit is a breaking change. So this is one way. Another way we can do is we can add a footer. So what we can do is I'm doing a git commit, multi-line commit. So I did git commit without the -m, and it says write the commit message. So another thing I can do is I can say chore MUI, no exclamation point, some description, and I can add a footer with all capital breaking change. And I can describe here, I have more room to describe why this change is a breaking change. Another thing I can do is I can use both. If I want, for example, to explain more about why this is a breaking change, I can add a footer and then add more explanation. So the exclamation point, you don't have a lot of explanation, you have only the description. The breaking change is specifically, you can write why this is a breaking change. So often if I want to write an additional explanation why this is a breaking change, I will add the footer as well. So this is another way we can signal a breaking change. So let's summarize what we talked now. Now, the thing I like about the breaking change, those are really commit. This is why I always add the exclamation point that we saw. Even if if I'm adding the footer, I will still add the exclamation point. The reason is it stand up more. Some Git UI will only display the first message and will cut the footers because there is no room. So this will really stand up. So I'll always add that exclamation point, even if I'm adding the footer. Although you can do either this or that, I will either add only the exclamation point or the exclamation point with the footer. I will never add only the footer because those commits, when you view those commits with exclamation point, those really stand up. So you know those commits have significant change. So if you have some kind of debugging with Git, those commits will really stand out and will be helpful to point them out when you're trying to debug your code. So they really stand out. There are two ways, like we said, to say that a commit has a breaking change. One is the exclamation point. So that always put a smile, that's the Seinfeld reference. But you didn't use an exclamation point. So don't use too many exclamation point. Only use the exclamation point when you have the breaking change. Okay, not in each sentence. I actually wanted to add in each sentence after this GIF, I wanted to add in each sentence exclamation point, but I thought it might be a bit confusing. So the exclamation point is one way, and another is to add the breaking change footer. And of course, you can add also both. If you need, the exclamation point is not enough and you want to explain why this is a breaking change, you can do both. But I never skip the exclamation point. So either put the exclamation point or both. I don't put the footer because it stands up more clearly if I put it on the top in the type section. Okay, continuing to move forward about the different parts of a conventional commit, let's move to description. So again, we have type we talked about, optional scope, we talked about breaking change, and we're talking about description now. Description is something that is required. So after you finish the type and scope and exclamation point, if it's a breaking change, you give a short, concise description of the change. So here's a few examples. I think there is a lot to explain about description. Just be concise and descriptive about the change. Remember that this is the thing that stands out when you go over the Git history. So try to be accurate and short with the description. So here is fetch mylib. It's a breaking change the fetch API. Type fixed without scope because maybe it's something relates to workspace, and description, workspace configuration, docs, and a scope of mylib, and a description, updated the contribution. So a few examples here. After the description comes the body. The body is optional. Also, you drop you leave a line empty from the top lines. So the top lines are type, scope, description. You leave a line empty, and then you start with an optional body. Body can have multiple paragraphs. So you can also have a body and then drop line and continue with multiple paragraphs. And the last section is the footers. So we talked about after the description, we have an empty line, a body, which can have multiple paragraphs, an empty line, and the footers. So the footers, there can be multiple footers, doesn't have to be one, but there's no empty line between them, like between body paragraphs. But they do distinguish between the body by something that is called word token. So word token is different in different organizations, but it references additional information. So for example, it might reference issue. If this commit solves an issue, so you might reference an issue, or you might reference if you paired programming with someone, you might reference that it's also written by another developer. And we talked about the breaking change footer. So let's talk about footers and give a few examples of word token. So after the body is optional, but you always have an empty line and then the footer. The body is optional, so you can jump instead of the body directly to the footers. The footers are distinguished by their word token. This is how you distinguish from the body. And a few examples of word token. So we're talking about footers. Here's a few examples of footers. So this is a commit with a lot of footers. Usually it's not the case. Usually you do mention if you solve an issue by doing closes or fixes depending on the organization, or resolves. If it's related to an issue, you write related. If you want to reference an issue, or write it, or you paired programming with someone so you can co-author it. Reviewed by, if it's reviewed by someone. This is the general example of word token, but it can change between organizations. So this is the conventional commits, right? So you have the type. We talked about the type of change, the scope, which part of your software is this change relates to, a description. You can add exclamation point for a breaking change. You can have an optional body with multiple paragraphs and multiple footers at the end with word token that reference additional information. So this is where things get a bit more interesting in my opinion. We're taking our conventional commit and now we can do certain automation based on our commit messages. What we're going to do is we are going to use something called semantic release, which will look at the commit messages, and based on that we'll perform the automatic actions that we want it to perform. We'll keep things simple, and we're just going to tell it to create a tag and increase the version. So what we're going to use, the automation, we're going to use it with GitHub Actions. So semantic release will track your version. This means we are no longer bumping our version in package.json. In fact, there are certain libraries that you'll notice. I think Angular is one of them. Let's see, Angular GitHub. Let's see here. I think it's here, package.json, maybe here. Maybe in the packages themselves. In the packages, maybe we'll look in one of the, let's see, common here in package.json here. So you see, there are certain libraries, even very popular libraries, that the version is, you'll see something like placeholder or something that doesn't really make sense. What this basically means that this package version is not maintained by a human being, but by certain automation. And we're going to do something similar with our code. Let's do that. Our code version is actually 0.0. Let's copy from Angular placeholder. So every developer will know that nobody is touching this version. This is automatically incremented by semantic release. So semantic release will track our version. It will tag releases with the version. It will publish a change log in the tag, and it will release the package to NPM. So if you want to see how you release the package to NPM, really simple. We're just going to keep things even a bit more simpler, but in our Academy site, you have a step-by-step guide to this entire lesson, and it's a bit more comprehensive with an example how to also publish to NPM. In this case, we are simply going to keep it simple and just create a tag with a version. We're not going to publish to NPM. We're going to keep things a bit more simple. But I think the point will be clear how to use semantic release. Basically, you just add plugins to semantic release, and if you add the plugin to publish to NPM, it will publish to NPM. But it does require you to create a NPM token and add it to your secrets, and there is a certain procedure here which I rather avoid to not show the token or secrets, all those confidential things. So we'll keep things a bit simple and keep the plugins as minimal, like create a tag, change log in the tag, increase the tag. So we'll show how to do it with a package called semantic-release. It's a very popular package for doing so, and fully automated version management and package publishing. And it works with plugins, so you can also add, there is also community plugins, like it can also publish, for example, to Slack, or do cool things that the community built around this solution. So it's very popular, very cool way to automate your release. And we'll give an example of how to automate, how we take our code and we automate our releases, our version, and we're going to use GitHub Actions to do so. So let's show an example of semantic release, taking our commit messages, updating our version automatically with GitHub Actions. So let's start with configuring semantic release, and I'll work hand-in-hand with the documentation, and we'll start by installing semantic release. I'll follow the docs installation, and there is an npm install that we need. So I'll copy the npm install and install semantic release. So after I installed semantic release, obviously my package.json should be configured, right, with it installed. Okay, so there are a few ways to configure semantic release. One is to create a configuration file, and the other is by just modifying the package.json and create the configuration inside the package.json. So this is what we're going to do. We're going to configure semantic release inside the package.json. Now, semantic release is configured under the package.json in the property called release. And we can go to their documentation, to the configuration section, and start configuring semantic release. And we'll start with the branches option. So we'll write here that we have branches. Now the branches can be an array, and the branches are what kind of, you often have release branch, which is often the main, but you can also have other branches. For example, you can have a branch called, for example, next, for the next, the pre-releases. And you have certain flows in your Git for certain, for release branch, for pre-release branch, for maintenance branches. And it's nice, it's a good read to follow to see the semantic release. They have here release workflow, so you can see their example of different branches. In our case, we'll keep it simple. We'll just have one release branch, which is our main branch. Great. Now, another thing that we want to configure is what kind of plugins do we want semantic release? Let's see in the configuration. What kind of plugins do we want? So let's see if we have here plugins. Here, plugins is an array. It has a default, which is basically you connect the semantic release, you connect plugins, where each plugin has a job and is doing something, some automatic action. So for example, the default is this. It has commit analyzer, with basically is going to analyze your conventional commits. You have release notes generator, which can, from the conventional commits, it can collect all the release notes that it will later put in the tag. You can use npm, semantic release npm, to publish to npm, and you can use semantic release GitHub to publish a tag in GitHub. Now, when we installed semantic release, it already shipped. If we go to node modules and we go to semantic release, we'll see that a lot of the plugins installed by simply installing semantic release. So you don't actually need to install any of those plugins, but there are also additional plugins that the community made, which has, I think there's links here for maybe in the resources or extending plugins. Somewhere here, there's official plugins, and there are also probably plugin community plugins. For example, you can connect semantic release to Slackbot to publish to publish to a Slack channel, which is also pretty cool. So you have different community plugins that you can connect as well, but those you will have to install them and you will have to add it in the plugins configuration. So you can leave the branches if you simply want the default plugins. The default plugins, as we mentioned, are those. But in this example, we won't publish the NPM, so we'll remove this plugin. So let's specify the plugins, and we'll have commit analyzer, we'll have release notes generator, and we'll simply remove semantic release NPM. We don't have to install any of them because they are installed when we installed semantic release. So this is the configuration for semantic release. Now let's create the automation. So I want every time when I push to the release branch, I want this automation to happen. All those automation on semantic release, I want them to happen whenever I push to main. Now in this example, what we'll do is we'll work with GitHub Actions. So I'll open a directory called GitHub. Inside there, I will put the directory called workflows. And inside the workflows, I will create a YAML file called release.yaml. Great. Now in this file, what we're going to do, let's put some comments. So we'll have help from Copilot. So it's GitHub Action workflow for using semantic release when we push to the main branch. Great. So the name will be release. It will work on when I push the branch's main, and it will have a job that's called release. It will run on Ubuntu latest. It will check out the code. I think at this time the version is 4. It will set up node. So we'll set up node to the latest LTS. Set up node to the latest LTS version. So in here we will have, I think it's LTS an asterisk for the latest LTS version, and we'll also include npm cache. So we'll also cache npm, and we are going to do npm clean install. This is what you usually want when you work with a CI, so no changes in package lock will occur, and it's just going to freeze and install everything with the correct version from package lock. And we're then going to just run npx semantic release. Now I do have here a few errors. I think it works with tabs instead of spaces. So in ideal world, I don't think I have a formatter for those YAML files, so I'll just manually do this. I apologize. Okay. Great. So in here, we'll fix those as well. Okay. So this is our Git workflow. An ideal, if this IDE is configured properly, I would just do format document, and then it will automatically indent. Also, it will recognize the tab size as spaces instead of tabs. And so, okay, so this is our workflow. Let's try to push this code and see what semantic release is doing. So I'll do a git status. I see that I have changes in package.json. I have GitHub, and I have node modules. This is why it's so important to add a git status after every command. I don't want the node modules to be included, so what I will do is I will create a git ignore file, and I'll specify in here that I want the node modules to be ignored. Now I'll do a git status, and I'll check all the changes are what I want them to be. Okay, great. So let's git add all of those changes, and let's do a git commit -m, and I'll call it feature CI created added semantic release automation. Now I'm going to push my code. So I created also, for this exercise, I created a remote repository in GitHub. So I pushed the code here. Now let's see the GitHub actions, what it's doing. I have some kind of failure in my YAML file, like line 10. Okay, so let's delete those comments. Again, it's an issue with the tabs. So let's delete those comments here. And I'll git add here, git commit -m, fix, CI, syntax, error, and release workflow. Notice that it's also good that we have those errors because it makes us write some additional conventional commit, and then we can see how the version is changed. So I'll git push origin main. And I have another error. So this time line 11. Let's just have a few spaces here. Let's just delete this and do another add and commit. Push again. So this is the last one. Okay, so this is now working. Let's see what is happening here. The workflow is starting. So we'll give it a few seconds to run, and then we'll inspect the result in a while. So our GitHub workflow is finished, and surprise, it failed. So I made a few mistakes along the way. Probably the main one is the arrogance of doing things in live coding. So let's fix the issues. I actually found in the GitHub release, in the semantic release documentation, you have recipe for GitHub Actions. So let's follow this recipe and follow the example I did and correct the mistakes. So a few things. They gave permission content read, which I think is the default. We can check out for checkout, but I think we can do that because that's the default without adding this permission. They did have add permissions here, but I don't think we need all those permissions because we're not creating issues or pull requests or ID token, but we do need the contents right because we are creating tags. So I'll add the permissions here, and we'll add contents read. That's good. Actually, I want the contents as write, not read. So I'll do this. Great. So this is great. They also set up Node. The newest, I think, is version 4. So let's do version 4. I put here the autocomplete and didn't change the version here. So they also took the latest LTS, which we did also, and they also npm CI clean install. They wrote I wrote it a bit shorter. And when you made a release, if you're publishing to NPM, you need to add the NPM token. So you need to go to the GitHub Actions. You need to go to the settings and add a secret and add the secret NPM token. We do need, if we want to publish our tags, we need the env GitHub token. So we do need here to add, the env GitHub token. We don't need the NPM token, but we do need secrets, and the secrets is GitHub token. Okay, so now that we fixed everything, so let's try to add git status, git add, and git commit -m, fix CI. The fix is semantic release permissions. And let's push our code again and go to the remote repository, go to actions to see our action is running, and let's give it a few seconds. Let's see if it's managed to run correctly. So it's running semantic release, and okay, so it does need issue or pull request permission like they did. So let's add all those permission issue and pull request they need also. So let's add both of those. And okay, let's remove the comment from here. And let's add and commit. Let's hope the permission is okay now. Yep. Let's go to actions to see our new action again. Great. It seems like it worked. Everything is successful. Now let's see what happened. So let's go to the tags. We see that 2 tags are created, and it created now a v1.01, and you see when I click it, it actually specified the commits of every tag. So let's see the first one. It actually did create before we fixed it. It wrote that error about the issues and pull requests that we need to add, but it actually did create the tag. So it actually write the change log as well. So you see the breaking change, the bug fixes, the features that are added, and this is all done automatically by semantic release. And we just used a few of their plugins, but you can customize it and add more plugins as your need when you want to release. What kind of automatic action do you want to add? So we saw how we can, having conventional commit, we can, based on our commit message, we can create automation of release, changelog, tags, and more. So that's pretty cool, and this is the power of not looking at the commits as just a chore, but working with a certain convention. So from my experience, if you're not forcing something among other developers, it simply will not happen. If you're writing a test and you're not forcing to run those tests in a CI, the tests are insignificant. If you have lint, but you're not forcing your CI to run lint, to run ESLint, so that's insignificant also. You can't, if you can do something automatic, if you can avoid the step of human supervision in certain steps and you can do them automatically, it's best to do it automatically. It's best to not force by a human being. So this is the same with conventional commits. We have good convention for the commits, but we have to force other developers and also ourselves to use that convention. That convention is now used in automatic releases of our software. So it's really important, in order for the release automation to work properly and reflect the proper release, the proper changelog, the proper tags, it's important that conventional commits will be enforced. So what we'll do now is we're going to use something called a package called commitlint, which checks the commit message it's in a pre-commit, it's not pre-commit, it's a pre-message hook. So it will check the message. So let's try and use the commitlint to lint our commit messages. So I'll go to guides and I'll start by installing it. So what you have here is you have an installation command, but in here you need to install some kind of because the package doesn't know which commitlint convention you are using. There are different conventions. For example, there is the Angular commitlint with certain Angular types that you can use. So if you're not sure what to start with, I would start with the config conventional. So let's install that. So I'll npm install, and I'll install config conventional. Actually, we'll keep this like that. So if you want to install something else other than the config conventional, for example, there is also very popular commitlint Angular config. So you can install with the CLI, you can install config Angular. So we're just using the config conventional, and we're installing also the CLI. So we installed 2 packages here. So this says we install in the commitlint scope, we install the CLI package and the config conventional. Now we need to create a config file for commitlint. So in here we'll use their example. So what they did here is created a bash command that will create the file commitlint config.js. So let's copy this and let's go and paste this command. And this command created a commitlint config, which basically says we are using the config conventional. In this file, for example, you can also type your own rules. So for example, you can add here, I don't remember the exact syntax, but you can, and let's see, so you can say, for example, I'm not sure about the syntax, this is auto Copilot suggestion, but I think it's correct here. So you can say define what your type is. Define rules and define what your type is. Maybe you want to remove one of those type in config conventional and add one of your own, so you can modify the type here. So there are different configuration. I don't remember them by heart, but you could follow the documentation for additional configuration that you want. So after this, you can run the config by there is a command to check the config, but it's best if you use some kind of commit message hook. So the commit message will be checked before the commit is actually created in your local repository. So for this, we're going to use Husky. So we're going to install Husky, and Husky will take care of your commit, of your Git hooks, stuff that happens before you commit, after you commit, checks to the message. So Husky is used for that. So let's install Husky, and let's use the npx husky init command to initiate Husky. And in here now, a directory is created, and we can create, for example, the pre-message hook. There is a pre-commit that does nothing, but we can create the commit message hook. This is the command where they're creating the commit message. So the result of this command is the file commit message, which is basically what it's doing is it's doing commitlint to the files that are going to be committed. And they are creating here Windows. This is for Windows users. And that's it for the commit lint. Your commit should be linted now. So let's try to check this out. So I'll do git status. And I'll check out the changes that I have. That seems reasonable. So I'll do a git add. And let's try to do a git commit -m. This commit is invalid because we don't have a type and a description. Okay, so I get an error. Oh, no test specified. No test specified, that doesn't relate to that. This relates to the pre-commit. Let's delete the pre-commit here. Let's do that again. Okay, let's git add again and git commit, the same commit before. And okay, unexpected token export. So let's change this file to MJS instead of JS. Oh. So it knows how to read the export. Let's try again. Okay, so now you see it worked. It found two problems. One problem is this commit is invalid because the subject may not be empty, type may not be empty. So let's try again. This time we'll do, let's do git status, git commit -m. This time we'll try with a type called this type is not supported. Some description. So now we have a problem because the type, it also validates that the type is either build, chore, CI, fetch, fix. So there is a list of types. Also, you can override it in the config rules and add your own types. So let's try again, git commit, and let's try it a proper lint now, a proper commit, sorry. We'll do a feature, created a commit lint pre-message hook. This time our commit worked. We git status, we can git push our code. And now we're forcing ourselves and all developers to write commit in conventional commit. So we know for sure that our release process is going to work with the right commit messages. We know that will be no developer that wants to write in its own special commit syntax, and everything is organized and conventional. So the last thing that I wanted to talk about is, if commit messages are so important, can I change a commit message? What if I did a commit message and I change my mind and want to change that commit message to look a bit differently? Commit messages are now important. It makes sense that I should know how to change them. So can I change a previous commit message? Well, the answer is depends. So let's start with a simple example. and change that commit message and show how to change that commit message. So let's go back to our code, and let's say I create some kind of change in my index.js of MUI lib, some change. And git adding this, I'll git status, and I'll git add this change, and I'll git commit -m feature MUI. This I want to change from feature to fixed. Like, I'm writing this commit message so you can understand that I have this commit and I want to change this this commit message. So if it's my last commit, it's quite easy, right? I can do a git commit -- amend, and I can just change this commit message, for example, to fix, right? And if I git log, I should see that it is changed to fix. This is one way. If I want to change my last commit, I can do a git commit with the amend flag. This is the simple case. Let's see a more advanced case. Let's say I have more commits and I don't want to change the last one. I just want to change the 10th one or the 20th one or something in the history I want to change. So let's add a few more changes. Let's add another commit. And let's add another commit. Okay, so I have like 3 commits that I just did. And if I do a git log, I actually not that pleased from the third one message, and I want to change that message. So how do I do it? Probably the most powerful tool you have for Git history editing, other than maybe Git cherry pick, is the Git rebase. Git rebase minus interactive. So Git minus interactive, I can say that I want to edit the third commit, because I want the third commit, I want the commit that I want to change. So it's head minus 3 commits back. So I'll do git rebase head tilde 3, and then I will go to the commit that I want to change. In this example, this is this, and I'll choose from pick to edit, or E, and I'll save this. And now I'm in editing mode of that commit. Okay, so in that case, I can do a git commit -- amend to change that commit from fix to, let's say, chore. Okay, I changed the commit. Now I'm closing the editing by doing git rebase -- continue. Great. So now if I look at my commits, I should see that it's changed to chore. So 2 ways I showed here to change commit message. One is git commit amend if I want to change the previous commit. And another way to change the commit message is by a powerful editing tool, Git Rebase Interactive. It lets you edit a certain commit, and then you do git commit -- amend to change that commit. Great. Now, I started this example by saying that you can change commit message. It depends. It's not all the time that you can change those commit messages. And let me explain what I mean. So if you look at how Git is built, and I'll give a link to this image that I found. So you have your files. This is the blue one here. You have the files that you're staging, that you're doing a git add for those files, and then you're doing a git commit, and you're placing that commit in your local, you're checking those files, those change files in your local repository. When you push it to remote repository. Okay, so why am I showing this? While I'm doing a commit changes for commits that are in my local repository, that's okay to edit those commits. Now, if those commits that I want to edit are already pushed to the remote repository, then it depends. It's not necessarily that I can edit those commits. Okay, it depends where you push it. So I'll say again because it's a bit complicated. Local repository, if your commit you're changing is in your local repository, you can edit it. If the commit you want to change is already pushed, it's not necessarily that you can edit it. What do I mean? If you push to a shared branch, like you have, as we said earlier, we have certain branches, we mark them in the package JSON, certain branches that have a certain goal. For example, the main branch is the release branch. You might have other branch like the maintenance branch, the alpha branch, the next branch, various branches with different purpose. And those branches are often shared among developers. It's not your branch, it's not something you open, your own PR, it's something that you share with other developers. So you cannot change that commit because that history of those commits are shared between the developers. So if the branch is shared among other developers and the commit is pushed, you cannot edit the message of that commit without messing the history of other developers, which you cannot do. Now, it doesn't mean that if the commit, this is where things get a bit tricky, it doesn't mean that if your commit is pushed to a remote repository, you cannot edit it if it's not a shared branch. If it's not a shared branch, you can edit even a pushed commit. So let's show an example. If I'm working on a feature, I'll probably do a git checkout -b some feature, right? Sorry, -c. Oh, sorry, -b some feature. Okay, so I'm opening a branch, and I'm going to let's say I'm going to git push origin. I'm going to push to that branch the 3 commits that I just created. And from those commits, I can go to my GitHub. I don't recall Academy's commit message, and I can open a PR. So this is a PR I'm opening for my changes, for the features that I'm working on. And this is not a shared branch. So if I'm doing now commits on that branch, for example, I edit 333, I'll git add, commit, and I'll git add here, another commit. Okay, so I can push those 2 commits that I just created. Okay, there's no problem. But let's say I want to change, and I already pushed those 2 commits, but I want to change the commit, not the last one, the one before it. So I'll do git rebase -i head 2, and I want to change the commit that I made here. I want to edit this commit. Okay, so I'm doing git commit -- amend to change the commit message to, let's say, feature. And now I'm doing a git rebase -- continue. And now I change the commit, but if I look at the PR, the push commits are not changed. It's only changed in my local repository. Now if I want to push those changed commit to this branch, I'll get an error. Now, the reason is that if you're changing a commit that is already pushed, you need to git push, force push that commit. So if you're force pushing, the commit message will change also in the remote. But you cannot force push on a shared branch. So on the main branch, you can't do that. On your PR branch, it's often that you force push to arrange your commits. It's quite often to do so. Actually, in your own PR branch, you'll do a lot of git push with force, but you do not do it on a shared branch. In fact, it's best there is protection rules for branches in your repository settings, and in there you can actually prevent, and I would say it's a must, you prevent force push for shared branches. So even if you want to change the commit message of a shared branch, you need to force all developers to not be able to do so. So to summarize what we just mentioned about commit message, if they're in local repository, if they are in your local repository here and not pushed, you can change them. If they are pushed, you need to change them, you need to force push. Force push is not recommended in shared branches. force push can be in your PR branch. So this is how you change your Git messages and the caveats about changing that commit message. So I hope we have, after this lesson, I hope we all have a different look about the importance of commit messages. So take the commit messages seriously. It's not only an easy to read history of your software evolution, but if you use the proper commits, it also will help you automating your release process. Use conventional commit when writing the commit message. So I'll place all the link in the lecture notes so you can find conventional commit, semantic release, commitlint, and our link to Academy's the article of this lesson. So write your commit messages using conventional commits. So conventional commits go over the specification. Conventional commits has a type, optional scope, a description, a body, and a footer. Go over all the notes here to understand how to write your commit messages properly. And using the same commit message convention, it's easier to understand the history of your commit messages. So the analogy we gave in this lecture is, think about you're reading Git commits, you're reading a story which is written by 1,000 authors or by one author keeping the same writing convention. Obviously, one author will be easier to read. So if you use conventional commit and you enforce it, all the developers are writing commit messages in the same way. It makes it much more readable. Plus, the commit that are breaking change, feature, fix stand out more, and you can immediately spot those important commits. And the commit message, proper commit message, also help you with your planning. So think about the commit message scope. If you're touching different scopes, is it the proper PR separation, or maybe you can split the PR of the task a bit differently? If you have a lot of fixed feature in the same PR, maybe you can take the fix to a different PR and merge it more to main. Those replanning by looking at the commit messages will really help you merge your code more often. Based on the commit convention, we can use semantic release to create automation. Semantic release works with plugins. So you connect to semantic release the plugins that you want in order to make semantic release automate maybe your tags, your version, your npm publish, your Slack publish. So you can install plugins and automate the release process based on your commit messages. And we can enforce all developers to use conventional commits. Remember, if it's not enforced, developers will probably forget or make it or write wrong commit message, which will make the release process not as professional as good as it should be. So if it's not enforced, it usually does not happen. So if you can enforce it automatically, it's best to do so. That's it. Thank you for listening. As a reminder, this entire lecture is a step-by-step guide, source code are all available in the Academy site. Again, I'll place a link in the description. If you like our content, feel free to go to the Academy site, click the GitHub icon, and remember to star us if you like. Everything in Academy is completely free, open source, MIT license. We don't want you to register, enter your email or stuff like that. Just enjoy the content and give us a star if you like what we are doing. That's it. Thank you for listening and see you in the next lesson.